All right, here's our day one video for laws of exponents. I gave you two papers when you walked into class, or if you were absent, you can grab the two papers from the back, and they just fold together to make a packet. And we're doing the first 3 pages of the packet today, and the second 3 pages tomorrow. So on this first page right here, we're talking about an exponent rule called the product rule. And I'm not going to do all these problems. I'm going to work a few and then tell you to go finish the rest and check it with the PDF in your Google Classroom. So the product rule says that if you are multiplying two bases that are the same, you add their exponents. And the reason why we can do this, if you think about what x cubed is, it's 3x's. And if I multiply that by x to the 4, which is 4x's, and then you'll see we have 7 x's altogether, and we add those up and we write it as x to the 7. Now we don't want to have to expand it out and think about it like that every time, and so that's a helpful reason to have our exponent rules. It makes our math go faster. And then in the second example, we have two bases, an x and a y, and it's the same. We're just going to add their exponents. This x is to the first power. If you ever see that there's no exponent, we understand it to be 1. So for the x bases, we add their exponents and get x to the 6th. And for the y bases, we add their exponents and get y to the 4. So a shortcut to remember is that when multiplying, you add exponents. Or you can use the word powers instead of exponents, you add the powers. So I'm going to leave most of these for you to do by yourself. I already mentioned how to do these. I want to start with talking about number 9, because what's different here is that the base is not a variable like everything that came before it. The base is an integer. So this is a bad math alert. Here's the most common wrong answer that I will get on this problem, is 4 to the 6th. And the mistake that the student is making here is multiplying the bases 2 times 2. What they did correctly was add the exponents. 3 plus 3 is 6. But here's why 4 to the 6 is not the answer. 4 to the 6 means I have 6 4s being multiplied. But that's actually not what the problem is saying. It's saying that I have 3 2s times another 3 2s. So what I really have 6 of is 2s. So it's 2 to the 6th. So anytime we're doing exponent rules and your base is a number, remember, you're not going to change. You're not doing math on the base. You leave the base the same, and you're doing the math on the exponents only. And then I'll let you try the rest of those yourself. Let's talk about the next page now, the quotient rule. So on this page, the product rule says when multiplying bases, you add the exponents. When dividing bases, so this is our quotient rule for division, when dividing, you subtract the exponents. Now in these two examples up here, there's actually two different situations happening. The first situation is when the exponent on top is bigger than the bottom. And the second situation is when the exponent on bottom is bigger than the one on top. So some different things happen here. When the exponent is bigger on top, we are going to subtract them. So we have x to the 5 minus 3, which is x squared. And this is sort of normal, air quotes around the word normal. And this happens, you get this normal situation when the exponent on top is bigger. When the exponent on bottom is bigger, in this example right here, notice how we're subtracting the powers in the denominator with the one with the bigger exponent. And then the 1 on top is a placeholder. So 1 over a to the 3 minus 2 is really 1 over a to the 1, which is just 1 over a. Now what we're going to be doing is finding wherever the exponent is bigger, moving the base to that side of the fraction, and then subtracting the exponents there. What's really happening here, this is an easier way of doing the negative exponent rule. So let's take this example real fast and work it like the one above was, where you just write the base down and then subtract 2 minus 3. This gives me a to the negative 1. Well, we don't leave exponents as negatives in our final answers. What we do instead is take the reciprocal of the base. So the base is a, its reciprocal is 1 over a, and then we change the exponent to a positive down there. So instead of doing this negative exponent rule every time, what we're going to do instead is whichever side of the fraction has the bigger exponent, we're going to put the base on that side and then do a regular subtraction there. And you'll catch on after I do a few examples. So I don't think we really need to do any where the bigger exponent is in the numerator, because that's the normal, air quote, situation. So number 1 is normal, 2 is normal, 3 is not normal because the bigger exponent is on the bottom, so we're going to practice this rule here. Wherever the bigger exponent is, you leave the base there, so the bigger exponent is in the denominator, so I'm going to put my base in the denominator. And then I subtract regularly. 5 minus 3, that's going to be 2 squared, and then you have to leave a 1 as a placeholder in the numerator. Number 4, the exponent on bottom is bigger, and 10 minus 6 is 4. On number 5, you'll notice that there are 2 bases in the numerator, a variable and an integer, and in the denominator there's only 1 base that matches. There's an x here, but nothing to go with the 2. So you can think about there being like a 2 to the 0 down here, because there aren't any 2's, right? And the top is a 2 to the 1. So 2 to the 1 minus 0 is just 2 to the 1, or 2. And then x to the 7 minus 3 is x to the 4. Let's look at number 7. There are 2 bases, a 4 and a y. So we're going to do them one at a time. So the first thing I want you to do is to look at the 4's and figure out where the biggest exponent is. Is it top or bottom? Numerator or denominator? And you'll notice it's the denominator. So what we're going to do is put our base of 4 down there and do our subtraction in the denominator. So 3 minus 2. And then for the y's, the bigger exponent's in the numerator on top. So I'm going to leave my y's on top and do the subtraction there. So that's going to give me y to the 6 over 4 to the 1, or just 4. Okay, I'm going to let you try the rest of those yourself. Let's look at page 3. There are 2 rules on page 3, but they're similar, so they go together. This first rule is called power to a power. So we have a power, x cubed, being raised to another power of 2. And this means that I have 2 sets of x cubed being multiplied together. So here's an x cubed times itself, another x cubed. Well, now that I'm multiplying and I know that I have to add the powers, this can be rewritten as x to the 6th. So it's just 3 times 2, because repeated addition is multiplication. So I have 2 groups of 3. And then over here, we're still raising powers to powers, but we have more than one base being multiplied inside this group. So this is my product in here that's being raised to this power outside. So that's why we call this power of a product. And when this happens, that power on the outside is getting multiplied by every power on the inside. So for the x, 2 times 5 is a power of 10. And for the y, 4 times 5 is a power of 20. So on these example situations, or for the shortcut by the word practice, just write to yourself that power to a power means to multiply powers. And so for number 1, we would have x to the 10. Number 4, the base is an integer, right? It's not a variable. So remember, we just leave the base as it is. It's a 6. And then follow the rule on the exponents. 3 times 7 is 21. Look at number 8. We have 3 bases in number 8, a 2, an a, and a b. The 2 and the a really have powers of 1. And the b has a power of 8, and all of those are going to get multiplied by 2. They're all being raised to the second power. So this becomes 2 to the 2, a to the 2, and b to the 16. In number 10, I'm just going to set up a portion of it for you, and then I'm going to work all of number 11. So for number 10, I just want to bring your attention to this part right here with the 0 exponent. So let's say you bring that outer exponent in and you do 0 times 10, which is 0. Remember that anything to the 0 power is 1. So use that to simplify your answer. And then let's look at 11. So on 11, we have 2 groups being multiplied. I have this group here and this group here. And I need to simplify all these exponents before I can do this multiplication that's between them. Right, that's my order of operations, exponents before multiplying. So I'm going to bring, in the first group, I'm going to bring that exponent of 9 in. This is really 3 to the 1. And 1 times 9 is 9, so that's 3 to the 9. And then a to the 8 times 9, which is 72. And then in the second group, that outer power is 2. I'm going to bring that into the 3 and the b. It's really 3 to the 1. And 1 times 2 is 2. And then the b is to the 5 times 2, or 10. Now I can multiply these 2 groups together. There's only one matching base, and that's the 3. Remember, you do not do 3 times 3. You just bring down the 3, because you have 9 3s and you're multiplying by 2 more. So you have 11 3s being multiplied all together, because now that we've switched to multiplication, we add the exponents. And there's no matching bases for the a or the b, so we just bring them down. And now I want you to try every other problem that I skipped and check with the answer key PDFs in your Google Classroom.